Good morning, everybody. Can everybody hear me okay? Oh, yeah, perfect. My name is Ravi Kanth, and I'm a senior principal with the Clarity Solution Group. I work out of their New York office. I focus on the financial services domain. Before we start, just a show of hands, how many of you work with AML? Oh, perfect. How many of you are familiar with Azure Machine Learning? Perfect. In today's session, we'll take a quick peek into what AML is. We will look at how AML solutions can be enhanced using machine learning and how specifically Azure ML helps us achieve this. We'll also have some time for Q&A in the end. AML stands for anti-money laundering. Before we get into what anti-money laundering is, let's look at what money laundering is. So money laundering is the process of making illegally gained assets appear legal. So this has three main steps. First is to introduce the illegitimate money into legitimate financial system without getting noticed. Second is to move the money around to create confusion. This is done typically by transferring the money through various accounts. And finally, additional actions help with integrating the money and making it appear clean. Money laundering really takes various forms, like, for example, structuring, where you're taking a big amount and then dividing into smaller amounts and trying to get it into the accounts so that you avoid the reporting limits that are set by the regulators. You also have other forms like using cash-intensive businesses. Like there are some businesses which by their very nature generate a lot of cash. So criminals or bad actors typically use those avenues to launder their money. You also have shell companies, which kind of hide who the true actors behind the companies are. Finally, you also have casinos, which are yet another way among the many other ways. So a bad actor could walk in with illegal cash, get some chips, spend a little time, go back to the counter, get the money, get his money back, return the chips, and claim those to be winnings from the casino. So all of these are various ways in which you could have money laundering. So the purpose of the AML rules is to help detect and report money laundering activity. So for the purpose of today's conversation, we'll be looking at AML from the purpose of banks and financial institutions. A typical AML flow looks somewhat like this. There are various feeds of data, like accounts, transactions, customer information, other historical information. You have information from the regulators, like specially designated nationals or persons of interest whose activity the regulators want to track. You also have the bank's own internal customer identification program data. You have any other data that the bank or financial institutions want to use. So using all these feeds, surveillance is conducted based on a predefined set of risk factors and scenarios. Most often than not, this is performed using a rule engine-based approach. So from this surveillance activity, potentially fraudulent transactions are flagged. And given the nature of these transactions, you don't mark them as fraud and report them immediately. You have a AML case desk, and then they investigate the transaction. And if they confirm that there is indeed a fraud, then that's reported to the regulator. So the report is called a suspicious activity report. So some of the common pitfalls of AML solutions are particularly around the rule engine-based approach, that it doesn't keep up with the dynamic nature of fraud detection, of the laundering activities of the criminals. The criminals are very clever and they keep constantly evolving. So you need the systems to be able to keep up with what the criminals do or the bad actors do. An example of this is, let's say, there is a threshold that you've established of over 10,000 euros or pounds. Let's report every transaction. Once the bad actors get a hang of it, they're going to structure and bring their transactions within that threshold. So how do you adapt to this, right? You have other, this is a simple scenario, but it's a real scenario. There are other pitfalls, like there is a lot of manual data collection going on and risk scoring. There is also a lack of social graph analysis. What we mean by that is, let's say there is a bad actor and you've identified a fraudulent transaction by this actor. Having a social graph of that, interaction graph of that actor within, even if it's within the confines of your own organization, helps you identify potentially any other actors that this actor has interacted with. So there is also very little customer segmentation at most places, or modeling of customer information. And finally, being able to apply this in real time in a scalable way. All of these are common issues that we have organizations facing. So to enhance AML fraud detection, some of the approach, one of the approaches is to be able to use machine learning. Obviously, we're not saying throw away your rule engine-based approach. So what we're saying is use a mix of rule engine as well as machine learning-based solutions. So the picture will help us understand this a little better as to what we're looking to achieve. So on the left side, you have most typical current state, and the right side of the picture is what we're looking to get to. So if you see the universe of transactions on the left, the fraudulent activities are marked by the inner rectangle, and then the oval marks the transactions that are flagged, and the circle marks the transactions that are actually investigated by the AML case management team. So as you can see, there are a lot of false positives, like those that don't intersect between the fraud and the flagged items. So there are a lot of false positives, and if the case management team, again, it's a manual effort, so they spend a lot of time trying to investigate all of these activities and all of the flagged transactions. And what we're looking to achieve with the AML plus rule engine-based approaches to kind of reduce the number of false positives and have better utilization of the AML case management team's time, as well as also to get a better priority to the identified items. So typically in a rule engine-based approach, you have first come, first serve kind of an approach to resolving the issues, whereas with using multiple scoring mechanisms, you could score the same transaction against multiple systems and then get an aggregate risk score that will help better prioritize your AML transactions. So how do we use machine learning for this? Right. This is a typical scenario that we just talked of, where you have incoming transactions and other data. There is batch surveillance happening, and you do the case management. With AML, with machine learning, you're kind of feeding machine learning data from incoming data as well as data from the case management system, and then you're enhancing your batch with not just the rule engine-based, but also the machine learning-based solutions. This also has the additional benefit of providing you the ability to wrap your machine learning-based algorithms into services, and then these can be consumed in real time as well. We'll get to how you can deploy, create, and use them in real time when we see the demo. So in machine learning with Azure, you have four major steps. One is identify, prepare, model, and deploy. So with identify, what we're looking to address is, hey, do we have a clear understanding of the business domain, and are we able to clearly identify the data sources? So once we have done that, the next step is to prepare the data. So with preparing the data, the key is selecting the data. Then once we have selected the data, we'll also have to make sure that the data that we've identified is clean, like there are no missing values, be able to apply any transformations that are required to get this data to a state that you can actually use. And then some of the typical things that you'd be looking for here are, hey, what are the attributes? Are the attributes consistently present? Do I have to convert any of the types from one to another to facilitate my feature engineering and so on? So once we've identified the data, once we've understood the domain, identified the data, cleaned and transformed it, the next step is to build our model. So the build step is really around identifying what machine learning algorithm best suits your purpose. So for this, you have multiple machine learning algorithms that are available, like there are supervised learning, unsupervised learning, and so on. So with supervised learning, the goal is to be able to use example or sample data, have the algorithm identify how the label is being arrived at, and then apply that on a test set of data so that you can evaluate, hey, is it performing to what the way I want it to perform, and then you'll be applying it in the real world. Whereas with unsupervised learning, there's really no label data, or there is no classified data. I mean, there is no example data, really. You just give it a set of data, and then you have it explore the organization of the data, and it tries to understand what the structure of the data is, and it tries to give you the simplest and best organization of the data that it can think of. Again, building the model, one of the keys is to be able to do feature engineering. Here, what you're looking at is, are there, of the raw variables, what makes most sense? How are these related to each other? And how do the machine learning algorithms use these features? So as part of this, you're also probably going to create additional features that are relevant to your task at hand. You'll also be potentially changing your algorithms based on the features that you've identified. So other than, there's also one other, within the supervised learning, there are a few different classes of algorithms. The first one is classification, where you're using data to predict a category. Then there is regression. Here, you're looking at predicting a value. Sometimes it could be a continuous value based on certain inputs that you've received. And then there is anomaly detection, where the goal is to identify data that is different than what you have, so something that's unusual for the data set. So all these three types come under supervised learning. And then within unsupervised learning, as we discussed before, it's primarily trying to organize data that doesn't really have any labels in it. Right? Again, Azure Machine Learning supports all of these with various algorithms. There is one algorithm that's unsupervised learning, that's the k-means clustering. Other than that, most of the others are supervised learning algorithms. So after you choose the model, the next step is to train the model. You randomly split the training data set, the data set that you have, into a training data set as well as a test data set, and then you run the model on the training data set. Once you finish training the data set, you would be evaluating it with the test data that you have. And finally, you identify the best model that addresses your need. After you're done with building the model, training and validating it, you'd be deploying it and trying to operationalize your model. One of the key things as you go through this steps is to make sure that you're building a pipeline, because this is not a once and done thing. Once you've built a model and deployed it, you want to be able to get new data constantly, and you want to maintain that model by training it from time to time with new data, and you want to keep it updated. So now let's just look at the Azure Machine Learning Studio. Before I go there, this is a cheat sheet that you have. Most of you have probably seen this. This is available on the Azure site. It gives you all the various algorithms that are there available for you to use and under what category they belong to. Just bear with me while I bring up the demo. Okay, so this is Azure Machine Learning Studio. Again, the key thing with Azure Machine Learning Studio is it provides visual workflow capabilities for data science. Like you have used Visual Studio for your regular programming, and this is it provides you similar capabilities for the data science workflows that you need to create. So you have you can create projects, and then your primary time would be spent creating experiments. Let me just open an experiment. So so the experiment is really a sequence of tasks that you're performing that are all wired together. We'll see how to create new steps and wire them together. On the left here, this is really your toolkit where you have various elements that you can use to perform various tasks. So you can, all your data sets will appear here. If you have any trained models, they'll appear here. You have the ability to convert from one format to another. Let's say you've built a data set and you want to export it somewhere else for use. You'll be able to do all of that here. The key things around, the key capabilities of this are around really being able to transform the data as you need, whether it's filtering the data or joining data, being able to add columns, add rows, clean missing data. All of these are elements that you don't have to really build. These are readily available for you to be able to drag and drop, and you can really focus on the experiment that you're looking to perform as opposed to the scaffolding and building the underlying code for the experiments. You also have a lot of support for being able to split data, or there are all the machine learning algorithms and models that are available for you to use: classification, clustering, regression, everything that we saw on the chart earlier. So let's, before we look into the code, before we look into the experiments, you can also use your Python or R modules if you have any. You can plug and play and use them within these experiments. Okay. Let's take a 10,000-foot view of how an experiment looks like. So this is an experiment that is already performed by me. In this experiment, the top portion that's highlighted now is really where the data has been, data is being aggregated. So we'll look at this, we'll run this, we'll change this, but I just want to give a 10,000-foot view of this experiment before we get into hands-on. So this is transaction data. There are multiple transaction files that are coming through, and then we have the ability to add them, and then there is selection of specific columns that's going on. On the other side, there is client data. So we're bringing in the client data, similarly joining both sets of data, selecting the specific columns that we want to perform the experiments on. And then there is the ability to split the data. This is training of the module. This is the actual model itself. This is the evaluation, and this is the scoring, and this is the evaluation. So all of these capabilities are available within the same environment. So you don't have to really go across various environments to be able to support your experiments. All of them can be done in exactly the same IDE. So let's look at how this works. So when this opens up, we'll see that there is some wiring that's already done. I just pre-built the data set so that we can build the machine learning model on this. Again, as I said, there is client data on each of the elements, you can actually go and visualize it, and this will give you information about what is the, sorry, that was a zip file. Once you've unpacked and combined the data sets. Okay, I haven't built this yet, so let me build it. It'll go through each of the elements and it'll build the experiment, and it'll collect and generate, it'll generate metrics, and then it'll provide us the ability to be able to visualize. So what you see by these icons next to it is it's building, and it builds it sequentially top to bottom as the workflow specifies. Okay. So this is just the data part of the experiment. We haven't done any machine learning on this yet. So we'll first look at the data. So this is raw data. We have the ability to look at, hey, are there any missing values? What is the feature type of this data element? What are the number of unique values, and so on. And it also gives you a fairly good idea of how the distribution is of the data points within this data element. You also have a good picture of how many rows there are, what is the number of columns, and so on. So you can use this visualization feature at every point that you have, you're touching the data. So whether it's when you're adding rows, whether you're selecting columns, or when you're finished finalizing the actual data set that you'll be running the machine learning experiments on. So we took data set of the client data, we took the data set of the transaction data, and finally we have done some transformations, and we arrived at a data set that we'll be running the machine learning experiments on here. So in here, I'm curious about what the distribution of the transaction types is. Okay, 89% of my transactions are credit card, there's 4% cash, and so on. Okay, the key is with AML, companies and financial institutions, even regulators, they're looking beyond just cash as a means for AML. They're looking now at the universe of transactions within that your organization supports to be able to track money laundering, because there's also the possibility that somebody prepays credit card and then claims the additional amount that they've paid back from the credit card company and use that as a money laundering technique. So all transactions could technically run through such an experiment, right? Okay. Now in here, let's add some machine learning capabilities and make sure that we create a model that we can operationalize through web service. So the very first thing is, let's make sure that we have our data ready. So again, it's very simple, drag and drop, and you need to make sure that you're wiring your elements right. Next, we need a model. I'm going to be using a multi-class decision forest. And let's create the train model, and we need to also score it. And finally, we need to evaluate this model. Okay. As you see, if there is any required data, then you will be prompted for it. So within the train model, let's first wire it, and then we'll see what is missing there. So within the train model, particularly given the type of model that we're using, we need to select which column is the label column. So in here, I have a column that's report flag. So that's my label column. And for this, I need to make sure that I'm wiring the data. So in the split data, I need to make sure that I've assigned the right kind of percentage of transactions that I want to train the model on. So I want to send 80% of my transactions for training, and then I want to use 20% of that for testing. And then once we are done with this, we want to evaluate the model. So let's save this, and we'll quickly run the experiment. So what is happening now is it's running through the data that we've created, the data set, and then it's splitting the data using the multi-class decision forest. It's training the model, and subsequently it will score the model, and finally evaluate, and it will generate metrics, and it will give us the ability to visualize the results. So let's see how the split data worked. So there are two data sets. Let's visualize data set 1. This is the 80%. So I have 834,000, that's the 80%. And this should be the 20%. $208,000, so we're good there. The train model, so this has taken that 80% and it's now identified some patterns. So let's see what patterns have been identified. If you see on the left, it has given you the identified patterns based on the trees that have been constructed. So it's just used one variable within this tree. But in the next one, let's see, maybe it used more. Okay, so it's used different variables. So it's identified patterns based on the data that we have given as example data to identify, hey, what is the optimal way to generate the label? Let's see what the scoring, how it happened. Okay. So here, it takes the test data set, and then using the trained model, it scores each of the labels. So here we said a report flag. This column is the label. So it scored it using the training data. And it's providing us the label as well as the probabilities for each of the labels that it has developed. And this is, again, just for our convenience to be able to go through and see, hey, how did it arrive at this particular label? Was there any other label that was considered, and what are the probability for those other labels? And then there is the evaluate model. This tells us how the model performed. Right. Again, this particular data set is hand-built, so it's 100% accurate. But again, in real world, this is probably not going to be a common occurrence. You'll find some deviation, and you should expect some deviation from a picture like this. But ideally, this gives you this element gives you the ability to look at, hey, what is the class that is predicted, and what is the actual class that was that came in as the label. So you'd be using this to identify, hey, what is the accuracy of my trained model. So having built this experiment and generated this trained model, now the next step is to set it up as a web service. So let's set it up as a predictive web service. What it does now is it picks up the appropriate elements, and then it creates the web service input and output. So our experiment has been collapsed into something that could be used from a web service, which is, excuse me. So our experiment has been converted to something that could be used from a web service. This is the output. We need to provide an input for our web service. Let's okay. Let's save this quickly. And then the next step, once we've created this, is to deploy the web service. When we deploy the web service, it automatically generates the URIs for us, and it also gives you sample code in C#, R, Python to be able to consume it. Okay, it's still building this model. One good thing about the Azure Machine Learning Studio is your experiment can have multiple machine learning models built in and trained. So you don't really have to have one experiment for each model. You can have multiple models within the same experiment. So let's deploy this. So it's going to take a little bit to deploy, so I'm going to start with something else that I built this morning. Actually, let's look at select a plan. So while it deploys, let's look at something that we already have. It gives you clear usage statistics and what response times it had, how many compute hours were consumed, whether there were any batch requests or were they all real-time requests. You have all the statistics provided in the dashboard. And then it also provides you the ability to test the web service. Let's see if, okay. So this is the web service that we created. You can also have the Swagger API for you to be able to use. That currently is unavailable, so it will be available after a little while it prepares it. So this is the experiment that we created. Let's just wait for it to show up for the first time. Okay, while we wait. While that comes up, I can show you something else. So this is how the configured screen is like. It gives you what your keys are. It gives you the ability to specify your name, enable logging. If there's any sample data that you want to enable, all of that you control through the configuration for the web service. And then there is also, for the consumption side, it provides you the request response URIs, the batch request URIs. It also gives you sample code I was mentioning earlier. There's also the Excel consumers, like you'll be able to download these files that are embedded with the URIs, and also they allow you to be able to test it if you're going to be using Excel as the interface for your machine learning activity. Okay, let's see if the still processing. Okay, so I'll take a pretty basic scenario. The report flag is the label, so that doesn't really matter for us. So this is a pretty straightforward transaction based on the feature set that I developed, that there is no suspect. I mean, this is a very clean transaction. And, I would expect to see a label of 0 for this, which is what we receive. Again, based on the feature set that you develop, you'll have use cases where you would expect to see some other labels. So this is a set where I'd expect to see a label of 1. And again, this really is coming from the web service that we developed and deployed. So you'll be able to use this in your in any of your applications for real-time or batch use. So where does this really come into play, and how does this help with case management, and how does it help enhance the AML activities? So if you look at a typical case management desktop, This is how a typical case management desktop would look like. You have the incoming queue of all the flagged items, and then you would look at, hey, these are the details within the item, and I'm going to work on it. Once the reviewer has identified whether it's a fraudulent transaction or not, they would add their notes in here and then move on to the next one, right? With the Azure Machine Learning or any other machine learning approach, you could potentially provide your case management team a much better and much more informed and prioritized case management queue. So here you've scored each of the transactions against multiple models. You've scored it with the legacy model, you're scoring with machine learning approach A, machine learning approach B, or however many approaches you have, and you're generating an aggregate score based on all of the scores that you've received. And also you can provide them much more detail on what has caused a particular transaction to be flagged or not. So we also talked about being able to do social network and social graph analysis. So with all the data that you've processed, you'll also be able to pretty easily generate social network graphs of your actors. Like if you have flagged a transaction, you'll be able to identify, okay, let's assume that this particular transaction belonged to this a user right here in the middle, and this user is interacting with wherever the cards are taking. And based on the strength of the number of transactions, the thickness of the card is increasing or decreasing, and this will help you identify, hey, within my universe of events or universe of customers, what are the other potential suspects that I should be following up on or investigating, right? So this is for case management. Again, think of other use cases where the web service, since it is now available, you'll be able to deploy it for, let's say, real-time use. And again, one of the key things with AML is not to alert the suspect, but rather to alert somebody on the inside so that they can investigate and alert the regulator. So you'll be able to use machine learning for use cases that you potentially are not able to support today, and also reduce the number of false positives. The same approach could potentially also be used in other areas like insurance fraud, for example, or for detecting insurance fraud, particularly around claims fraud, and also for underwriting analysis, where you'll be able to use these machine learning techniques to be able to provide better underwriting support. I'll just take a pause here. Any questions?
How do you, the UI, how do you automate that? How do you make that part of the CI pipeline so you generate that machine learning kind of pipeline?
So the question was, how do you provide this information to the UI, right?
No, so how do you, so you went through, configured through UI. What if I want to build that through my CI rather than through the UI? Can you do that? No, through machine learning.
So build your experiment through code.
Yeah, through code, yeah.
Rather than
Through, yeah. Can I drive this through code?
Yeah, you should be able to do it with code, definitely. The key is, again, this particular environment is for the visual workflow development for for data science activities. So when you're using Microsoft Azure Machine Learning Studio, primarily most of your activities will be drag and drop. So if you had, let's say, pre-built code for Python or R to be able to execute a task, then you will be able to bring in that code and use it within the workflow. But if you want to execute all of this within code, then this is probably not the best environment for you. This is really for being able to use the features that are in here and bring code that you want to embed within this workflow. Okay. Any other questions? Go ahead.
how do you actually get some rules, or how is the machine learning making decisions? Like, how are you telling of what you consider to be fraudulent transactions?
Excellent. So let's look at the data set that we generated here. So in the data set that we used for this experiment, there is a column called the report flag. So this is historical data. So in the historical data, this column is the report flag. So these are all transactions that in the past have been flagged and reported and confirmed to have been fraud. So we've, through the processing of the data, so we had, as I was showing you in the customer database, we had 19 columns here. We had 16 columns here, okay. And then in the transaction data, we had probably 19 columns. So we merged all of them and we created the features. We extracted the features that we wanted to use, right? So that report column, when we went to create the machine learning model, right? Let me go back to when we were creating the experiment and when we were creating the model, we had a step where we chose which column was the label column. So let me find one experiment where I haven't built it to the predictive service. Okay. So in this, there is one element here in the training. So you'll see that there is a label column here. So this is the report flag. So we are telling it based on historical data, this column is giving you whether this is a fraudulent transaction or not. So it's using that to understand from the data, hey, what patterns of data have this flag set to true or false or whatever code. If it's a multi-classification, what is the associated code with it? And then when you bring new data in, it looks for any pattern. So I was showing you this trained model with the various trees that it built, right? So all of these are the various approaches that it used to say, hey, this is for this pattern of data, this is the score that I've assigned. So when you get new data, it's going to try and match up against these existing patterns that it identified, and based on the best match, it's going to give you whether this is a fraudulent activity, not fraudulent, or some other special kind of code. Okay? Any other questions? Okay. One of the other things that you can consider is, like when you're really building machine learning based tools for your user, when you're focused on data science, this is really a significantly small portion now, given the capabilities that are built into the tool. Most of your time is really going to be spent on trying to understand your data and arrive at, hey, what are the features that I want to engineer and what is the best way that I can get the additional features out of my data set. Some of the times you'll notice that this is not a once and done kind of a thing. It's not even a step A, step B, step C. It's very iterative in nature. So you'll be going through multiple iterations, and then you'll probably identify, hey, I don't have some data that I need to get. Probably I don't have it available, or I need to augment it with something that's available outside my ecosystem. So you'll have to iterate through the steps, identify what data really supports these algorithms and what gives you the best results to be able to identify the fraud activities. So some of the additional use cases that you'll find is you'll be augmenting this with social data, social media data. There's probably Twitter feeds or Facebook feeds that you'll be bringing in and augmenting your own transactional data to identify if there are any fraud patterns that you could look at, right? And I guess there was an insurance use case. This gentleman here, you were talking of insurance and claims fraud. So if there is a user, there's an insured who's claiming that they were in an accident on a certain day, and you find that their Facebook is showing pictures of a holiday in some other place, then that's potentially a fraudulent activity that you want to flag, right? So you could definitely use. So it's not a once and done. It's not just the data you have you have the ability to bring in all different types of data and use this to be able to merge and create the data set that will help you best identify the fraud. And again, it's not just one. Let me show you that example. So most of the times you'll find that this is not, I just pick my one model and I'm done with the model and it's making me happy. Even if you're happy with the model, if it's your first one, you want to make sure that you're trying out alternate approaches and you're evaluating multiple models. So in this, you'll find that on the left here, we are using a regression-based approach. And then on the right here, I'm using a clustering-based approach. So within the same experiment, I'm using multiple models, and then you evaluate each model's performance with the other. Again, it's not just two. This is a play area which allows you to have as many models as you can accommodate. Again, there is a hard limit of 10 GB. You cannot have data denser than 10 GB. But other than that, you should be able to, within those limits, have as many have as many models as you want, evaluate and compare. And once you're happy with one, then take that, convert it to a web service, deploy, use it for either batch or real-time purposes, and be able to operationalize it. And the other advantage with this is, as you might have seen, I made a change in here in the split. I think earlier it was 0.3, I made it a 0.8. If I brought in new data, my pipeline still remains. I don't have to, if I'm having new data, I don't have to rebuild this whole thing each time. So this pipeline exists for you to be able to retrain your model from time to time with newer data. Again, if you're selecting new columns or you're bringing in new columns, then obviously there is some work to be done. But the scaffolding and majority of the pipeline exists, and you'll be able to reuse it. So that's a pretty powerful feature to have. Yes, please. So when you say A/B testing, that's really around scenario for, like let's say marketing, where you have scenario A, scenario B, which is giving me most. This is not connected with that. This is within the machine learning data science field, where the left side is really giving you the training data set. So when you have a data set, you want to make sure that your model is performing accurately. So the way you do it is you have a historical data set or some data set where you have labels that are already marked, data that is already marked as fraudulent or not fraudulent. You will randomly take a portion of it, and you will first train the model. So you'll ask it to, hey, use this data to teach yourself what is a fraudulent and what is not a fraudulent transaction. And then after it has done the training, you want to use the rest of the sample to test it. So here, it ignores that flag field. So it uses the rest of the data to generate its flag based on the learning that it has done. And then it compares the flag that it generated with the flag that's already present. So this is not that A/B testing. That A/B testing is in more of what the users have liked, like approach A, approach B. This is not that. Any other questions? Okay, I guess I'll give you back 10 more minutes. If anybody has any questions, I'll be around here, so feel free to ask.